Hello, everyone. Okay, so let's get to it. I have some questions on 3D geometry for you. One is the slightly above and beyond what you need, but hopefully you'll find it enjoyable. Okay. If not, then apologies. Okay, so we start with the problem one, which I haven't finished last time, so I just wanted to go through that. So you have a cube with an edge of the cube of length A. You need to find the radius of the sphere passing through A, B1, E, and F. A, B1, E, and F, where CE equals EF equals FC1. Now, this normally, you would not have a diagram here, right? You would not have a diagram. You would need to do it by yourself. Okay. Helpfully, we have a diagram. The board, yes. The board is here. So what we need a sphere. So if we have a sphere, that means somewhere there's a point which is the center of that sphere. Okay. And that means that these distances are equal to the radius of the sphere. So suppose O is the center, O with coordinates x, y, and z is the center of the sphere. Okay. And that means that OB1 is equal to OF is equal to OE and equal to OA, which is equal to the radius of the sphere, which is what we are looking for. So let's write down the values. So the vector OB1 is equal to, you know what? It doesn't matter. OB1 is minus x minus y, a minus z. Vector OF is equal to minus x, a minus y, 2a over 3 minus z. Then OE, is equal to minus x, a minus y, and a over 3 minus z. Aha, interesting. And OA is equal to a minus x minus y minus z. Now, which ones should I use? I mean, that's a good question. Which ones should I use? OE and OF. Yeah, very good. We should use OE and OF because they are on the same vertical line, and being equidistant from those 2 points actually means we are we can find the z coordinate. And we'll basically, if you have 2 points, and if you are equally distant from these 2 points, that means you are normally, if you were on a plane, that would be the perpendicular bisector. But now it's 3D, so it's going to be the bisecting plane. It's a plane which was bisecting these 2 points, and this distance is equal to this distance, because any point you take on this plane would be equidistant from the 2 given points. So if this is F and this is E, any point on that plane, any point on the plane is equidistant from E and F. Okay, so that's what you can use, OF and OE. I'm going to equate them. So OF is equal to OE, and that means OF is minus x squared plus a minus y squared plus 2a over 3 minus z squared equals minus x squared plus a minus y squared plus a over 3 minus z squared. And you can see that this cancels, and we get these. We get these points. So 2a over 3 minus z is equal to a over 3 minus z squared. That either means 2a over 3 minus z equals a over 3 minus z, or 2a over 3 minus z equals z minus a over 3. Does everyone understand why? Do you understand how this follows from here? Yes, you're taking the square root, and you need to take the positive and the negative versions, because if you have a squared equals b squared, that either means a equals b or a equals minus b. So it's two things. Yeah, because the positive doesn't allow you to find z. Positive is nonsense. Like 2a over 3 equals a over 3, which is wrong. Very easy to prove. Well, it only works if a is 0, and a is clearly not. So that's nonsense. And here we have 2z is equal to 3a over 3. So z is equal to a over 2, which was very easy to predict, right? Because if you are equidistant from point E and F, so you're somewhere in the plane connecting the midpoints of these. So you're somewhere in this plane. You don't have to be inside, but you're certainly in that plane. Okay, and then we will use, so we found Z. That's very nice. Can we find X somehow? Oh, let's see if we can make OA and OB equal. Yeah, OA and OB, that works. So now we take OA equals OB, OB1, of course. So that's OA, which is a minus x squared plus minus y squared plus minus z squared equals minus x squared plus minus y squared plus a minus z squared. Okay. Actually thinking about it, I don't think that will allow us to find y. Oh no, actually it will. It will allow us to find y, yeah. Okay, no, not y. Hopefully it will find x. Let's see. So y cancels. So a minus x, so a minus x squared plus z. So we know that z is a over 2. So a squared over 4 equals minus x squared plus a minus z, which is a over 2 squared again. Oh, that cancels. Nice. And now we have a minus x squared equals x squared, because we can get rid of the minus, doesn't matter. Okay, so it's either a minus x equals x or a minus x equals minus x. The second one is nonsense. So we have this x equals a over 2 again. Very nice. And finding y, well, I would take OE and doesn't really matter which one, OE and OA. OE equals OA. Okay, and OE. OE is minus x squared plus a minus y squared plus a over 3 minus z squared equals OA, which is a minus x squared plus minus y squared plus minus z squared. And what do we get? Well, we know a, we know x, so x is a over 2 squared plus a minus y squared plus a over 3 minus a over 2. That makes it a over 6. So a squared over 36 equals a minus a over 2. So that's a over 2 squared plus y squared plus z squared, that is a over 2 squared again. So a over 2 cancels. We get a minus y squared equals y squared plus, that's a squared over 4 minus a squared over 36. Okay, hopefully I didn't make a mistake. I'll just double check myself. And okay. Well, from here, a squared plus minus 2ay plus y squared equals y squared plus a squared over 4 minus a squared over 36. Y cancels. All right, a cancels as well. So it's a minus 2y. So divide by a. A minus 2y equals a over 4 minus a over 36. Okay, so 2y is a minus a over 4 plus a over 36 equals 36, 9. 36a minus 9a plus a over 36. You should get 14. Or maybe not. Let's see. Oh, 28. 36 minus 9 is 27 plus 28a over 36, which is 14a over 18, which is 7a over 9. And then finally, y is 7a over 18. And that's the values. And then it's a simple method. Well, radius is, take the easiest one. Radius is OB1. So use magenta. Radius is modulus of OA. Sorry, OB1. I wanted to take OB1. And that is minus x squared plus minus y squared plus a minus z squared square root, of course. So here that is a squared over 4 plus a what is it? A 49 a squared over 18, 324 plus a squared over 4, and that should be equal to a square root 211 over 18. If it's not, let me know, but it should be. Okay, that's how you do it. I mean, that's a problem. That's the method, and you can get quite creative. So you don't just look at what you would do before you start doing it. So a little bit of trial and error in terms of, well, which ones do you do first? Which ones are the easiest to do? Okay. All right. Problem 2. So SABC is a pyramid. Point M is on the z-axis, and point N is on the SBC ABC plane. I meant. Oh no, SBC plane. Vector Mn is 1/3, 1/3, 0. Find the coordinates of point M. Okay, so would be nice. Well, it's a pyramid, so okay. Pyramid. Okay. S is on here. A, B, C. So A is 0, 0, 0. B is 1, 0, 0. C is 0, 1, 0. And S is 0, 0, 2. It's actually very useful because you can see that AB is perpendicular to AC and perpendicular to AS. So the pyramid looks more like this. This is S, this is A, this is B, this is C. Okay, point M is on the z-axis. But S is on the z-axis, right? Because this is the z-axis. B is on the x-axis. X-axis. And C is on the y-axis. Because C is 0, 1, 0. And B is 1, 0, 0. And S is 0, 0, 2. So M M is on the z-axis. We don't know if it's in the pyramid or not. So I just draw it here. M, point M. N is on the SBC plane. SBC. Okay, so point M is in this plane. N is in this plane. MN is 1/3, 1/3, 0. Aha. So MN is, so if this is 0, that means that MN has 0 component in the Z direction. What that means is that point M is in fact here. Point M is here. MN. Okay. So what would I do here? Well, first of all, I would find the equation of the plane. First, find the equation of the plane. Equation of the plane SBC. Okay, and we know that equation of a plane is ax plus by plus cz equals d. So we can substitute all 3 points into the equation. Sub SBC into equation. So substituting S is going to be 0 plus 0 plus 2c is equal to d. Substituting B, that's going to be A plus 0 equals D. And substituting C, it's going to be 0 plus B plus 0 equals D. So from here, we can see that C is equal to D over 2, A is equal to D, and B is equal to D. Substitute that back into the equation. It's going to be dx plus dy plus d over 2 z equals d. Divide both sides by d, and we get x plus y plus z over 2 equals 1. And that's the equation of the plane. Okay. Now we know that M has coordinates 0, 0, z, and N has coordinates x, y, and z. But we also know that N is in that plane. And Mn is equal to, Mn is x, y, 0, which is equal to 1/3, 1/3, 0. That means x is equal to 1/3, and y is equal to 1/3, and z is equal to 0. That's interesting. Oh no, 0 is 0. We don't know z. Okay, 0 is 0. So x is 1/3, y is 1/3. All right, that's useful because now we can find z. Z over 2 plus 1/3 plus 1/3 is equal to 1. So z over 2 is equal to 1 minus 2/3, which is 1/3. So z is equal to 2/3. Ah, lovely. So the answer, M, has coordinates 0, 0, 2/3. That's it. That's the answer. Now, problem 3. This is the problem where as I was talking about, this is I'm going to do some unusual stuff. You might be familiar with it. Has anyone encountered the triple product of vectors? Has anyone done the triple scalar product? It's a cross product and the scalar product together. Okay. Sorry, I'll answer the question about from Men. The question is, in problem 16 in the maths assignment, how are we supposed to find the angle between two lines that don't intersect? Okay. That's a good question. So, two lines that don't intersect. I have to switch off my fancy. How do I select none? Okay. If you take a line, so lines can be parallel. That means the angle between them is 0, of course. Lines can intersect, and that means the angle between them is this. Okay. However, if lines don't intersect and don't and are not parallel, they're like this. They're called skew lines. To find the angle between skew lines means to find the angle between their direction vectors. Okay, so if you hold them like this, yes, they don't intersect, but you can clearly see there's an angle between them. Okay, so skew lines lie in parallel planes. Skew lines lie in parallel planes. So if you have a plane like this and another plane like this, and you have a line in the first one and a line in the second and a line in the second one. So these lines are clearly not parallel, and clearly they don't intersect because they lie in parallel planes. So what you need to do, so this is plane alpha and this is plane beta, and this is line L and this is line M. You need to find another line which is parallel to L but lies in that plane. So this is L, let's call it L star. So L belongs to plane alpha. M belongs to plane beta. L star is parallel to L. And L star belongs to plane beta. So because L star is parallel to L, that means the angle between M and L is equal to the angle between M and L star. So all you need to find the angle between M and L star, and that's the angle that you're looking for. Angle theta. Theta is the angle you need. So how do you do this? How do you do this problem? Well, you need to find the direction vector of L. This is, let's call it U. And M has a direction vector V. So let U is the direction vector of L, and V is the direction vector of M. The angle between L and M is the same as the angle between U and V. It might sound hard, but actually it's not. It's exactly all you need is to find any vector parallel to L, any vector parallel to M, and then find the angle between them. Does that make sense? Of course, you don't need to find a parallel vector. No. All you need is to find the direction vector of L and the directional vector of M. So this is what you actually need to do. This is just the explanation of how you can have an angle between two lines which don't intersect. And this is what you actually need to do. What you actually need to do. If you're still confused, I'll make it even simpler for you. You take the first line, you find a point which is on that line and another point on that line. So A and B. And vector AB is your direction vector. You take the second line, you take any 2 points on that line, C and D. And this would be the direction vector of the second line. So find AB, find CD, and then use find the angle, find angle between AB and CD. So does that make sense? Anna? Okay, I'll wait for the answer. Okay, so we have a pyramid. We have a pyramid. Okay. Let's call it S, A, B, C. It doesn't look like this, but it doesn't have to. Find the equation of the ABC plane. Okay. Well, it's not the easiest thing in the world to do. I mean, there are different ways you can do this. Find the equation of ABC. So this is a plane ABC. And it has equation. Okay, well, let's do it straightforward. Hopefully, by plus cz equals d. It's the equation. Then you sub all the 3 points. So 3x, 3a plus minus 2b plus c equals d. Second one, we have 3a minus plus b plus 5c equals d. And 4a plus 3c equals d. So what can we do here? Well, let's try to eliminate them one by one. No, I would multiply the second one by 2 and add it to the first one. And that would make 6, 9a. So I'm multiplying this by 2, so 6a plus this one. So this is 2b minus 2b, that's 0. 10c plus c, that's 11c. And that's equal to 2d. Oh, 3d. And we have 4a plus 3c equals 2d. Okay, now we multiply this by 3. And multiply this by minus 11. What do we get? So it gets 27a plus 33c equals 9d. I multiply this by minus 11, minus 44a minus 33c equals minus 11d. Adding them together, I get 44. So adding them together, I get 44 minus 27, something. Minus 2d. 3 plus 4, 17. So minus 17a is a is 2/17 of d. Okay, not as pretty as the previous one, but we're getting there. We're getting places. We found a, and then we can find c. The task is to find a, b, and c in terms of d, as you remember in the previous one. Then you take this one and add it here. So a, that's going to be 8 over 17d plus 3c equals d. So 3c is equal to 17 minus 8. 17 minus 8, that is 9d over 17. So c is equal to 3d over 17. Okay, and now we can find b. We can use the second equation to find b. So 3a plus b plus 5c equals d. So 3a, which is 6d on 17, plus b plus 5c, that's 15c on 17 equals d. Okay, so what 15d on 17? Just 21. So 17 minus 21, that's minus 4. So b is minus 4d on 17. Okay, now we sub that in. I've used all the available space, but I'm going to shrink that. Okay, so we take this finally, and we write down ax. So this is 217d x plus b, which is minus 4d on 17 y, plus c, which is 3d on 17 z, equals d, and d predictably cancels. And we multiply the whole thing by 17, we get 2x minus 4y plus 3z equals 17. Oh, okay, not too bad. I thought it's going to be worse. That's the equation of the plane ABC. Now, we need to find the height of the pyramid. Height of the pyramid is the distance between point S and the plane. And if you remember, height of the pyramid, height is the distance from S to plane ABC. And there's like an equation in the assignment. There was an equation that you can use. I honestly forgot the equation. Just let me pick that up. I think it's just, yeah, you just sub the point into the equation, find the modulus. But yeah, let me pick that up. I don't remember unnecessary formulas. Neither should you. Oh, it depends. If you can. I had a student who had this fantastic ability of remembering formulas, which I would never, ever be able to remember. The shortest distance. So here's the bit from the assignment. So what we need to do is we need to find h, which is the modulus of AXO. So there's going to be 2 multiplied by, point S is 0, 0, 0. So that makes life easier. So 2 multiplied by 0 plus minus 4 multiplied by 0 plus 3, 3 times 0 minus 17 divided by square root of 2 squared plus 4 squared plus 3 squared. And that makes it 17 over 4 plus 16 plus 9, which is 17 over root 29. Okay. That's the height of the pyramid. Now, area of the base. Well, there are different ways you can find the area of the base. Area of base area of base. You can find vector AB. You can find vector AB, which is 0, 3, 4. You can find vector BC. No, AC. Let's do AC. And that is 1, 2, 2. You can find the angle between, we can find the cosine of the angle between AB and AC, which is the product, the dot product. It's 0 times 1 plus 3 times 2 plus 4 times 2 over the length of AB, which is 5, as you can already see, it's 5, multiplied by square root of 1 plus 4 plus 4. So that's 4 plus 4 is, 9, square root of 9. Okay, that's beautiful. So that's going to be 5 times 3, 15. And on top, it's going to be 6 plus 8. 6 plus 8 is 14. So the angle, cosine of the angle. Then we can find the sine of the angle. Sine of the angle AB and AC is equal to 1 minus cos squared of that angle, which is square root, of course. It's the square root of 1 minus 14 squared over 15 squared, which is yikes, 225 minus 196. 225, 29. Oh, square root of 29 over 15. Interesting. So why do I need sine? Because the area of the triangle ABC is 1/2 AB times AC multiplied by sine of the angle sine theta, which is 1/2 multiplied by AB, which is 5, times AC, which is not 3. I still can't believe it's 3. Okay, it's 3. It is 3 times 3 multiplied by square root of 29 over 15. 15 cancels, and it's square root of 29 over 2. Beautiful. It's a beautiful answer. Square root of 29 over 2. Sine is this. We don't need sine. We have the distance is 17 over square root of 29. And to find the volume. Well, we know the volume is area times height. Volume is the area times height, which is 1/3 area times height, of course. So it's going to be 1/3 multiplied by area, which is square root of 29 over 2 times height, which is 17 over square root 29. And that is 17 over 6. Okay. That's the volume of the pyramid. Now stuff gets more interesting. First of all, there is such a thing in maths known as the mixed product. It's also known as the triple product of vectors, triple scalar product, triple scalar product, also known, aka mixed product. It's usually written as vector A, B, C, like this. Sometimes it is written in a weird way. A times B, C. Oh, that's unwanted. Apologies. Yeah, or sometimes written as A dot B times C. These are all the same thing. These are all equivalent. Now, the interesting thing about it is that if you take three vectors, and you draw a parallelepiped is like a cuboid, but not. This is vector A, B, and C. A, B, C. So basically, if you take any three vectors, like any three vectors, like this, right? And you draw a parallelepiped. So basically, like a cuboid based on three. But cuboids have rectangular size. These don't have to be. So the parallelepiped is like a cuboid, but with it could be any three non-coplanar vectors can have a parallelepiped drawn. Does that make sense? Do you understand the picture with a parallelepiped? Just one. Do you understand how you can draw a parallelepiped? Parallelepiped is a shape, is a three-dimensional shape. It's like a box, like this. If you had to take any three vectors, you can draw. So A, B, C. You can draw a parallelepiped. No? Yes? Come on. Don't. Right. Right. Okay, thank you. Now, the volume of a parallelepiped, volume of a parallelepiped, drawn on three vectors is the modulus of A, B, C. So if you take the triple scalar product of vectors, it gives you the volume of a parallelepiped. So let's try that. And for simplicity, we're going to take vectors SA, SB, and SC. So SA, okay, I'll copy that. Just okay, vector SA is 3 minus 2, 1. SB is 315 and SC is 403. Now to find the you need to know matrices. If you don't know matrices, don't worry too much about it. But the vector SA, SB, SC, the triple product of these three vectors is equal to the determinant of the matrix drawn on the three vectors. So it's 3 minus 2, 1, 3, 1, 5, and 4, 0, 3. So if you take any three vectors and put them in a matrix and find the determinant, then you will find the volume. There are different ways of finding the determinant. Don't worry, you don't need to know determinant for now. Okay, determinant of a matrix. But just as show of hands, who has done determinant of a 3x3 matrix in school, or perhaps by yourself? Okay, nice. All right. So you might know this method. So finding a determinant. So finding the determinant, you take these three, then you take these, and then you take these three. So it's going to be 3. Don't use yellow. Don't use yellow. 3 times 1 times 3 plus minus 2 times 5 times 4 plus 3 times 0 times 1 minus, and then you subtract, then 1 times 1 times 4 minus, how am I using yellow? Oh, apologies. 1 times 1 times 4, then minus 2 times 3 times 3, and minus 5 times 0 times 3, and the determinant, that's how, it's 9 minus 20 minus 4 plus 18, which is 5 minus 2, that's 3. Something went wrong. It should have been 17. 3 minus 2, 1, 3, 1, 5, 4, 0, 3. 3 minus 2, 1, 3, 1, 5, 4 minus 4, 0, 3. 3, 1, 3, so that's 9. 40, of course. Minus 40. That's 2 times 5 times 4. That's 40. Minus 4. That's okay. And I believe that's minus 17. 9 plus 18, that's 27. 27 minus 4, that's 23. 40 minus 23, that's minus 17. So the volume of the parallelepiped is 17, because obviously we take the modulus of that. Okay, so how is that how is that even related? Well, look at the parallelepiped. Do you remember the volume of the parallelepiped? Volume is base times height. But the pyramid is 1/3 base times height. But if you look at the pyramid and look at the parallelepiped, you will see that the pyramid has half the base because it has a base which is 2 times smaller. You can see that the base, okay, that's not a very good picture. The base of the pyramid is half the base of this one. So it's going to be a third times half the base of the parallelepiped times height, which is 1/6 of the volume of the parallelepiped. It's a weird name. So the volume of a pyramid is 1/6 the volume of the pyramid. Do you understand that? Do you understand why the pyramid is 1/6 of the volume of the parallelepiped? A simple example. Please let me know. Please let me know that you understand. If you don't, if you take a cube and you draw a pyramid inside the cube, the volume of the pyramid is 1/6 of the volume of the cube because it's half the base and then it's a third. Okay, and volume of the parallelepiped is 17, but the volume of this was 17/6, which is complete agreement. Volume of the pyramid is 1/6 of the volume of the parallelepiped, which is 17/6. Ta-da! So we could have found the volume by just straightforward. The volume of any triangular pyramid can be found just like that. All you need to do is just multiply the 3 vectors. It's a simple action. Well, you need to learn how to do this, but it is a simple thing. You can see it is one line. So the problem suddenly becomes a one-line problem. All I need to do is write out the 3 vectors. So 3 minus 2, 1. 3, 1, 5. 4, 0, 3, and put a 1/6 in front, and that gives me the volume of the pyramid, which is 17/6. If you find it beautiful, let me know. And another thing that if you take a cross product, which we haven't done, of course, but I'll do it anyways. The cross product. Cross product has another meaning. Cross product. It's A times B. But interestingly, if you take 2 vectors, A and B, and you multiply them using the cross product, it will give you the area. So the modulus of the cross product of 2 vectors is equal to the area of parallelogram. Okay. So if you have 2 vectors, let's say AB and AC. AB, which is 034, and AC is 122. If you were to find if you have vector A, B, and AC, the area of the parallelogram would be this, but the area of the triangle would be half of that. Area of triangle ABC would be 1/2 of the modulus of the cross product of the two vectors of vectors AB and AC. AB and AC. Now, finding the cross product is also you use for the cross product you use matrices. So AB multiplied by AC. I'm just going to show you how to do this without really explaining how. I, J, K, these are the base vectors. And here I write 0, 3, 4, 1, 2, 2. And I just find the determinant, and there's going to be 6i plus 4j minus 3k minus 8i. Did I forget something? 8i. No, haven't forgotten anything. And so that is the vector is -2, 4, -3. Now the vector product is a vector, of course, but now we need to find the modulus of the vector, modulus of AB times AC, and that is square root of 2 squared plus 4 squared plus 3 squared, which is 4 plus 16 plus 9, square root of 29. Looks familiar, doesn't it? So the area is 1/2 multiplied by square root of 29, which is square root of 29 over 2. Have we seen this today? We have. The area of the triangle was indeed square root of 29 over 2. So you could have found this also just one single action. You have 1/2 of the cross product of the vectors. Vectors are extremely powerful, and there's so much for you to learn. That's kind of my point today. Okay, so hopefully you got something out of it. Hopefully you got something useful for yourself. These formulas, yes, you can use them, but there are other ways of doing the same thing. Okay. Yes, the triple scalar product is just the determinant of the matrix. Absolutely. And interestingly enough, in a matrix, if you change two lines, if you change the order of the vectors, that means you change, for example, you change the first and the second line, the determinant becomes negative. The determinant changes to its negative counterpart. And that is also true for the scalar product. Scalar product, if you change the order of vectors in a vector product, that changes the sign. Okay, moving on. So I've kind of done problem 4. So let me do problem 5, and if we have time, we'll do problem 4. So this is physics now. You have a water cylinder. The water level is kept constant. So water is being added constantly. At what height h should you make a small opening to maximize the distance? So you've probably seen this picture. So is it Pascal's law? Pascal's law. Probably not that one. Oh no, not Pascal's. It was Torricelli. Torricelli. Yes, here it is. Okay. Well, you've seen this experiment done in school, hopefully. Spouting can experiment. You can see that at the top, the speed is going to be not so high. Here, the speed is going to be bigger, and here the speed is going to be even bigger, but because the height is lower, it won't go as far. So the question is, where is that sweet spot? Where's that sweet spot which will take you the furthest? Okay, L max. Does everyone understand the question? Where do we need to make a hole? Because if you make it higher, you have a longer time, but smaller speed. Well, let's first of all find the use projectile motion equation. So time to fall from height h. Well, it's a suvat. S is h. The initial velocity is 0 because it's falling. Dropping vertical to fall. Yeah, just we need the time. If you release something from a height h, how long it will take to fall. Final velocity is we don't need. Acceleration is 10, and time is question mark. So of course we use suvat. So we use s is equal to ut plus 1/2 at squared. And so that means h is equal to 0 plus 5t squared. So t is equal to h over 5 square root. Ooh, interesting. That's the time it takes to fall from a height h. Originally it's 2h over g, but yeah. Okay. Distance covered. So distance traveled in time t is L is equal to t multiplied by velocity v, which is v multiplied by square root h over 5. Okay, where v is the nozzle velocity. V is the velocity. Not to get confused with this v. This v is nothing. So vertical suvat. Okay, so we found this. We found L is the distance in terms of v and h. We don't know v yet. Now we do need to find v. So let's look at what happens here. So let's say we have some water coming out of the nozzle. Water of mass m traveling with velocity v. Velocity v. As this water leaves, this water, the top part of the water, drops down by a small amount. very small amount. Okay. Yes, you are correct. The water level is kept constant, but in order to find the speed, we need to keep the water level constant just to make sure that the speed doesn't change. Okay, that the speed doesn't change. So that's why we say we keep adding water. We say, what if we didn't add water and we just for a very short time measure it? So the water doesn't have enough time. So let t tau be a short time. Okay, delta t be the short time in which the height water drop is insignificant. Okay. I'm just thinking how to put it this way. We can say that if a mass of, okay, we don't need that. In that very short time, a mass m of water left the nozzle. In that short time, a mass, let's call it delta m of water left the nozzle. And an equal amount of water was removed from the top. So the change in gravitational potential energy of the water, you can think of it as that this piece of water has been removed from here. So this is that water. And that means that this water drops by this much, so h minus h. This is the change in gravitational potential energy of the water is delta m g h minus h. So it's the drop in height. So you think of it as this amount of water which was on top is now moved down and removed from the container. Doesn't matter that it's different actual molecules, but we're talking about the gravitational potential energy. What has changed? Well, we removed some of the water from the top and we've taken it out from the middle. So the water that was on top is effectively now in the middle. So the change in gravitational potential energy is mg h minus h, and the kinetic energy, change in kinetic energy of the water, is 1/2 delta m v squared. So from here we can find 1/2 mv delta mv squared is equal to delta m g h minus h. So delta m cancels and we have v is equal to 2g h minus h. over, oh, square root. Nice. Finally, we can use that into the expression for L. So L is equal to square root of 2g h minus h multiplied by h over, well, 2h over g. Let's put it this way, 2h over g. Okay, and L is equal to, we can put it into one square root, so 2g h minus h multiplied by 2h over g. G cancels, so L is equal to square root of 4h h minus h. So the distance clearly depends on the height. Okay, so how would we find h at which L is L max? Differentiate, thank you, of course. We need to differentiate, we need to find the derivative of L with respect to h. Okay, so how do we do that? Well, let's open the brackets. It's going to be 4h minus 4h squared to the power 1/2. There's going to be 1/2 multiplied by 4h minus 4h squared to the power minus 1/2 multiplied by 4h minus 8h, and that has to equal to 0. The derivative, when it's max, it has to equal to 0. Now this cannot be equal to 0, and that means that 4h is equal to 8h. So it turns out that h is h over 2. Interesting. And L max is, well, square root of 4 multiplied by h over 2 multiplied by h minus h over 2 is going to be 2h over 2, which is h. Oh, interesting. The maximum distance that you can achieve is actually equal to h. L max is h. That's quite interesting. And interestingly, you saw that g cancels. So on Mars, that wouldn't be different. Or on the moon, it's going to be the same thing. It only depends on the height of the cylinder. Okay, now I have some stuff to think about for the evening. Yeah, so yeah, that's about it. I will probably take one question from the audience. Maybe some question you're confused with in the assignment. Can I help? Oh, yeah, that's 2 questions. Problem 6 is the amplitude of the oscillation refers to the horizontal displacement or angular displacement. Let me see. I was problem 6. Problem 6. Happy with both. Yeah. I meant linear displacement from the middle. You can approximate. You can use small angle approximations. Okay. So it's a horizontal displacement. but you can use small angular approximation. In the kinetic energy paradox, how do you get the velocity of the planet in the second frame of reference? What do you mean, the velocity of the planet? You don't. That's the thing. Oh, like V dash. Is that what you're talking about? Okay. Well, if you have a planet, so this is your planet, and this is the car. And in a stationary frame, stationary frame. So the car moves forward mv, and the planet moves back mv. So we have v is equal to m over mv, right? After the car accelerates with the velocity v, this moves back. In the frame of the second car, so the planet slows down. So velocity, the final velocity of the planet is the velocity of the car, velocity of the second car, minus m over mv. That's how you get the formula. 1 minus m over mv. So the velocity was v, and now it is decreased by that amount. That's where you get the amount. Does that make sense? I have. Okay. So that's sorry for keeping everyone in the dark, because that's private. There was a private message. Here's the thing we're talking about. We're talking about where does v dash come from. So yeah. Okay. Resham asks, in math problem 3, what does it mean when it says containing the height of this triangle dropped from a dash? Maths problem 3. Okay, so you have A, B, C, A, B, C. Write down the equation of a line passing through A and contain the height of this triangle dropped from A. So if a height is a perpendicular line drawn from A, so the height would be like this, perpendicular to BC. So this is known as the height. This is H, so AH is the height of triangle ABC. Any triangle has 3 heights. So 1, 2, and 3. Three heights. Okay. Yeah. Does that make sense? All right. Height is perpendicular to the base. That is fine. Yeah, you can have a triangle like this, and the height goes outside the triangle. Yeah. BC. You could have this situation. Okay. All right. So enjoy the rest of the week and submitting the work, and I'll see you in a week's time. You're welcome.